1. Jupiter is more massive than all other planets combined, and then some. Let's try a thought experiment. Take Saturn, with its glorious rings. Take Uranus and Neptune, the ice giants. Take Mars, Venus, Mercury, and even our own precious Earth. Collect them all. Now, put them on one side of a cosmic scale. On the other side, place only Jupiter. The scale wouldn't just tip, it would shatter. Jupiter contains more than 2.5 times the mass of all other planets in our solar system combined. This isn't just a size difference, it's a fundamental shift in category. 2. If Earth were a grape, Jupiter would be a basketball. It's a simple analogy, but it works. Over 1,300 Earths could fit inside Jupiter by volume. If you were to unwrap Jupiter and lay it flat, its surface area is more than 120 times larger than Earth's. It is a true giant in every sense of the word. 3. Jupiter is a failed star. This sounds like an insult, but it's a profound statement about its nature. Jupiter is made of the same stuff as the Sun, primarily hydrogen and helium. It's a gas giant. If it had been about 80 times more massive when it formed, the pressure and temperature at its core would have been high enough to ignite nuclear fusion. It would have become a star, and we would be living in a binary star system. Our solar system was on the verge of being a profoundly different place, for it almost doesn't qualify as a planet by one definition. There's a concept in astrophysics called the center of mass between two orbiting bodies. For the Earth and Sun, that point is deep inside the Sun. But Jupiter is so massive that the barycenter between it and the Sun is actually outside the Sun's surface, about 7% of the Sun's radius above it. This means, technically, Jupiter and the Sun orbit a common point in empty space. It's the only planet in our solar system for which this is true. 5. Jupiter's gravity is immense. If you could stand on a platform in Jupiter's upper atmosphere, you would weigh about 2.5 times what you weigh on Earth. A 180-pound, 82 kilograms person would feel like they weigh 450 pounds, 204 kilograms. This immense gravity is the engine that drives nearly everything we're about to discuss. 6. It has the shortest day in the solar system, despite its colossal size. Jupiter is a dizzyingly fast spinner. A day on Jupiter 1 full rotation is just 9 hours and 56 minutes long. This incredible rotational speed has dramatic consequences for its shape and its weather. 7. Jupiter is not a sphere. It's a squashed ball because it spins so fast. Jupiter bulges out significantly at its equator and is flattened at its poles. This shape is called an oblate spheroid. The diameter at its equator is about 9,000 kilometers wider than the diameter from pole to pole. This isn't a subtle effect. It's a visible, dramatic distortion caused by its own rotational fury. 8. The Great Red Spot is a centrifugal hurricane. It's Jupiter's most famous feature. A swirling crimson eye staring out into space. But it's not just a storm. It's an anticyclone, a high-pressure system that has been raging for at least 350 years, since we first pointed telescopes at the planet. 9. The Great Red Spot is wider than planet Earth for centuries. The storm was large enough to contain 3 Earths, while recent observations show it has been shrinkier. Mystery scientists are still trying to solve. It is still comfortably larger than our entire world. 10. The winds inside. It reached 432 kilometers per hour, 268 miles per hour. That's faster than any hurricane ever recorded on Earth. And what's truly bizarre is that the storm itself is quite calm at its center. with winds moving much slower. The fury is all at the edges. 11. The storm is incredibly deep. Data from NASA's Juno spacecraft revealed that the Great Red Spot isn't just a surface feature. Its roots extend deep into the atmosphere. At least 300 to 500 kilometers, about 180 to 300 miles down. That's far deeper than Earth's oceans. 12. We don't know why. Its red dot, this is one of Jupiter's most enduring mysteries. The leading theory is that chemicals from deep within Jupiter's atmosphere are churned up by the storm, and when exposed to the sun's ultraviolet light, they undergo a chemical reaction that turns them a reddish-brown color. But we don't know for sure which chromophores, or color-bearing molecules, are responsible. 13. Jupiter has strings of pearls. At its southern hemisphere, there is a chain of massive, white, oval-shaped storms. There are usually between 6 and 9 of them, each a powerful anti-satellite, marching in a row like a celestial necklace. 14. Jupiter's north and south poles are unrecognizable. For centuries, we only saw Jupiter's striped, banded middle. The Juno mission gave us our first clear look at the poles, and they are stunningly different. Instead of bands, the poles are home to a cluster of giant, geometric cyclones. The North Pole has one central cyclone with 8 others spinning around it. The South Pole has one in the middle, with 5 orbiting it. They are strangely stable, a configuration that has baffled planetary scientists. 15. The bands are jet streams. Jupiter's famous stripes are called zones, the lighter bands, and belts, the darker bands. These are not surface markings. They are vast jet streams of gas flowing in opposite directions at incredible speeds. The zones are rising, cooling gas, while the belts are falling, warming gas. 16. The color differences are due to chemistry. The lighter zones are white or yellow because they are higher in the atmosphere, and the rising gas forms bright white ammonia ice crystals. The darker, reddish-brown belts are lower, warmer, and their chemistry is more complex, likely involving sulfur and phosphorus compounds. 17. Shallow lightning exists on Jupiter. On Earth, lightning originates from water clouds. For a long time, scientists thought the same was true on Jupiter. But Juno discovered frequent, smaller lightning flashes high up in the atmosphere, in regions where liquid water can't exist. It seems to be generated in clouds made of an ammonia water slush, a process completely alien to us. 18. Jupiter's lightning is upside down compared to Earth's on Earth. Lightning tends to happen most around the equator. On Jupiter, it's concentrated near the poles. This is because the sun heats Jupiter's equator more evenly, preventing the buildup of convective energy needed for big storms. The poles, however, have more atmospheric instability, creating the perfect conditions for a light show. 19. It rains helium on Jupiter, deep inside the planet. The pressure is so immense that it squeezes hydrogen and helium. Helium, being heavier, condenses into droplets and rains down through the lighter liquid hydrogen, falling towards the core. This helium rain is thought to be a major source of Jupiter's internal heat. 20. Jupiter radiates more heat than it receives from the sun. Jupiter is still cooling down from its formation. 4.5 billion years ago, this internal heat, generated by gravitational contraction and helium rain, the Kelvin-Helmholtz mechanism, means the planet emits nearly twice as much energy as it gets from the sun. It has its own internal engine. 1. There are giant mush balls of ammonia and ice in its atmosphere. A new theory, based on Juno data, suggests that massive, slushy hailstones made of water ammonia ice form high up. These mush balls become so heavy they plunge deep into the atmosphere, carrying ammonia and water far below the cloud tops and explaining some of the strange chemical readings Juno has sent back. Asterisk. 22. Jupiter has no solid surface. If you tried to land on Jupiter, you would just keep falling. The gas would get denser and hotter, eventually crushing and vaporizing your spacecraft. The atmosphere seamlessly transitions into a bizarre, planet-spanning ocean. 23. Deep inside Jupiter, hydrogen becomes a metal. About a quarter of the way into the planet, the pressure exceeds 2 million times that of Earth's atmosphere. Here, hydrogen, normally a gas, is compressed so violently that its electrons are stripped away from their protons. It becomes a liquid that conducts electricity like a metal. Liquid metallic hydrogen. The vast majority of Jupiter's interior is made of this exotic substance. 24. Jupiter's core is a fuzzy mystery. For years, we thought Jupiter had a small, dense, rocky core. But data from the Juno mission has shown that the core is actually fuzzy or diluted. It seems the heavy elements are not in a neat ball at the center, but are mixed into the metallic hydrogen mantle above, spanning up to half the planet's radius. This suggests a violent collision with another massive body early in Jupiter's history may have shattered its original core. 25. Jupiter's magnetic field is the strongest of any planet. This is a direct result of that vast, swirling ocean of liquid metallic hydrogen. It acts like a giant electrical dynamo. The resulting magnetic field is nearly 20,000 times stronger than Earth's. It is the largest and most powerful structure in the solar system after the Sun's own heliosphere. 26. Magnetosphere is absolutely enormous. If our eyes could see it, Jupiter's magnetosphere would appear larger than the full moon in our night sky. It's so big that it extends past the orbit of Saturn on the side facing away from the Sun. A magnet tail that stretches for hundreds of millions of kilometers. Asterisk. 27. The area around Jupiter is a radiation death trap. This powerful magnetic field traps charged particles from the solar wind, accelerating them to incredible speeds. The radiation belts around Jupiter are thousands of times more intense than Earth's Van Allen belts. Any unshielded spacecraft or human flying through them would be fried in an instant. The Juno spacecraft has to fly in a highly elliptical orbit to dip in quickly, and then fly far away to protect its electronics. 28. Jupiter has the most powerful auroras in the solar system. Just like on Earth, when charged particles are funneled by the magnetic field towards the poles, they slam into atmospheric gases and create light. Jupiter's auroras are permanent, hundreds of times more powerful than ours, and they shine brightly in ultraviolet and X-ray light, invisible to the naked eye. 29. The moons power some of the auroras. Jupiter's moons, particularly Io, orbit within this intense magnetic field. As Io moves, it creates a powerful electrical current of flux tube that connects it directly to Jupiter. This tube funnels particles onto Jupiter's atmosphere, creating a specific footprint in the aurora, like a glowing spot that follows Io's path. The other Galilean moons create fainter footprints as well. Asterisk. 30. Jupiter has faint rings. When you think of rings, you think of Saturn, but Jupiter has its own ring system. Discovered by the Voyager 1 spacecraft in 1979, They are just very faint and tenuous, made of dark dust rather than bright ice. 3.1. The rings are made from its own moons. The dust that makes up Jupiter's rings is constantly being kicked up by micrometeoroid impacts on its four small inner moons, Metis, Adrastea, and Thebe. The rings are essentially the dusty debris of these tiny worlds, because the dust is always falling into Jupiter. The rings have to be constantly replenished, like a celestial waterfall of sand. Asterisk 3.2. The four Galilean moons can be seen with binoculars. Io. Europa, Ganymede, and Callisto are so large and bright that on a clear night, a simple pair of binoculars is enough to spot them as tiny points of light dancing around Jupiter. It's a breathtaking link to Galileo's own revolutionary observations. Point 3.3. These moons are in a perfect rhythmic dance. Io, Europa, and Ganymede are locked in what's called an orbital resonance. For every one orbit Ganymede makes, Europa makes exactly 2. And for every 2 orbits Europa makes, Io makes exactly 4. This precise 1 to 2 to 4 resonance means they constantly pull on each other in the same spot. A gravitational tug of war that has profound consequences, especially for the innermost moon. Io, this is the engine of chaos and creation in the Jovian system. Asterisk 3.4. Io has over 400 active volcanoes. Earth has active volcanoes, but Io is in another league. Its entire surface is a canvas of volcanic calderas, lava flows, and plumes of sulfur erupting into space. It is a world of pure, raw geological violence. 35. Its volcanism is caused by tidal heating. Io is caught in a gravitational torture device. Jupiter's immense gravity pulls on it, trying to lock it in place. But the rhythmic tugs from Europa and Ganymede in their orbital resonance prevent this. They pull Io into a slightly elliptical orbit. This means as Io gets closer to Jupiter, it's stretched, and as it moves away, it relaxes. This constant flexing generates immense friction and heat in its interior, enough to melt its mantle and power its endless eruptions. Asterisk 36. Io's plumes can erupt 500 kilometers, 300 miles high, because Io has a very thin atmosphere and low gravity. Its volcanic plumes can shoot material incredibly high into space, creating giant, umbrella-shaped clouds of sulfur and sulfur dioxide gas that then fall back down, blanketing the surface. 3.7. Io's surface is a riot of color. Io looks like a moldy pizza for a reason. Its surface is covered in various forms of sulfur. Yellows, reds, whites, blacks, and greens are all different sulfur compounds, frozen onto the surface at different temperatures. It's a palette created by hellish chemistry. 38. It has mountains taller than Mount Everest. Despite being constantly repaved by lava, Io has massive mountains. Some, like the Busol Montaz, are over 17 kilometers, 10.6 miles high. They are not volcanic, but are likely tectonic plates of crust being pushed upwards by compressive stress within Io's crust. 39. Io has a thin atmosphere of sulfur dioxide. The atmosphere is created by the outgassing from its volcanoes and by sunlight, sublimating the sulfur dioxide frost on its surface. It's incredibly thin, about 1 billion times less dense than Earth's atmosphere. 40. Io creates a plasma torus around Jupiter. The material spewed out by Io's volcanoes doesn't all fall back down. Some of it is stripped away by Jupiter's magnetosphere and becomes ionized, electrically charged. This creates a donut-shaped cloud of plasma. called the Io plasma Taurus, that co-rotates with Jupiter, glowing in ultraviolet light. 41. Io has a liquid iron core. Its intense volcanic activity and its interaction with Jupiter's magnetic field strongly suggests that Io, like Earth, has a molten iron or iron sulfide core. For 2. Europa's surface is one of the smoothest in the solar system. Unlike most moons, which are pockmarked with craters, Europa's surface is remarkably smooth and bright. It has very few impact craters, indicating that its surface is geologically very young and is constantly being renewed from below. 43. Europa is covered in a shell of water ice. This shell is estimated to be between 15 to 25 kilometers, 10 to 15 miles thick. It is one of the most reflective surfaces in the solar system, bouncing back over 60% of the sunlight that hits it. 44. Beneath the ice, there is a global ocean of liquid salt water. This is the big one. Multiple lines of evidence, from the way Europa interacts with Jupiter's magnetic field, to the strange tectonic features on its surface, point to the existence of a vast liquid water ocean beneath the ice. 45. Europa's ocean may contain more water than all of Earth's oceans combined. While Europa is only the size of our moon, its ocean is thought to be incredibly deep, perhaps 60 to 150 kilometers, 40 to 100 miles deep. If this is true, it holds more than twice the amount of liquid water found on our own blue planet. 46. This ocean is kept liquid by tidal heating, just like Io. Europa is flexed by Jupiter's gravity, though less intensely. This tidal heating provides just enough energy to keep the water from freezing solid, despite the surface temperature being a frigid minus 160 degrees Celsius. Opening parenthesis, minus 260 degrees Fahrenheit, closing parenthesis. 47. The scars on its surface are chaos terrain. Europa's surface is covered in long, dark cracks and bizarre, jumbled landscapes called chaos terrain. Scientists believe these are places where the ice shell has melted, broken apart, and refrozen, like icebergs in Earth's polar seas. This suggests a dynamic interaction between the ocean and the icy shell. 48. Europa may have water vapor plumes erupting into space. The Hubble Space Telescope has detected tantalizing evidence of plumes of water vapor erupting from Europa's surface, particularly in its southern hemisphere. If confirmed, this would mean we could sample Europa's ocean without ever having to drill through the ice. 49. The ocean floor may have hydrothermal vents. The tidal heating that warms the ocean likely also causes geological activity on Europa's seafloor. This could create hydrothermal vents similar to the black smokers found in Earth's deep oceans. On Earth, these vents are teeming with life that survives on chemical energy, not sunlight. 50. Europa is a top candidate in the search for extraterrestrial life. Liquid water? Check. A source of energy, tidal heating? Check. The necessary chemical building blocks, likely delivered by asteroids and comets? Check. Europa has all the key ingredients believed to be necessary for life. The question of whether life exists in its dark, deep ocean is one of the driving forces of modern planetary science. 51. NASA's Europa Clipper mission is on its way to answer these questions. NASA is sending a dedicated mission called the Europa Clipper. It won't land, but it will perform dozens of close flybys, using radar to measure the ice thickness, a spectrometer to analyze surface composition, and magnetometers to confirm the ocean's depth and salinity. It is designed to find out if Europa truly has the potential for life. Asterisk 52. Ganymede is the largest moon in the solar system, with a diameter of 5,268 kilometers, 3,273 miles. It is bigger than Mercury and dwarf planet Pluto. If it orbited the Sun instead of Jupiter, it would easily be classified as a planet. 53. It is the only moon with its own magnetic field. This is Ganymede's most remarkable feature. It generates its own intrinsic magnetosphere within Jupiter's much larger one. This is likely created by a convecting liquid iron core, similar to Earth's. No other moon we know of has this. 54. Ganymede's surface is a mix of old and new. Its surface is a striking patchwork of two distinct terrain types. There are dark, ancient, heavily cratered regions, suggesting they are billions of years old. And then there are lighter, younger, grooved regions marked by complex tectonic patterns. This indicates a dramatic geological history. 55. It also has a subsurface, ocean like Europa. Ganymede is believed to have a massive saltwater ocean hidden beneath its crust. Evidence from the Galileo and Hubble missions suggests this ocean is trapped between two layers of isoclub sandwich model with ice on top, then liquid water, then another layer of high-pressure ice at the very bottom. 56. Its ocean is even larger than Europa's. Estimates suggest Ganymede's ocean could be 100 kilometers 60 miles, thick 10 times deeper than Earth's oceans, and contain more water than all of Earth's surface water. 57. It has a tenuous oxygen atmosphere. Don't get too excited. It's not breathable. This thin atmosphere is created when charged particles from Jupiter's magnetosphere bombard the icy surface, splitting water molecules into hydrogen and oxygen. The light hydrogen escapes, leaving a whisper of oxygen behind. 58. The grooved terrain was formed by tectonic activity. The younger, lighter parts of Ganymede's surface are covered in vast systems of grooves and ridges. This is thought to be the result of cryovolcanism or tectonic activity, where the moon's crust was stretched and pulled apart, possibly when water from the interior flooded and refroze. 59. The European Space Agency's mission is headed there. The Jupiter ICY moons. Explorer JUICE is a mission dedicated to studying Ganymede, as well as Callisto and Europa. Its primary goal is to characterize these ocean worlds as a class of planetary bodies. In a historic first, JUICE will eventually go into orbit around Ganymede, becoming the first spacecraft to orbit a moon other than our own. 60. Callisto is the most heavily cratered object in the solar system. Its surface is absolutely saturated with impact craters. This tells us that its surface is extremely old and geologically dead. Unlike the other Galilean moons, it has no active volcanoes or tectonics to erase the scars of bombardment from the last 4 billion years. 61. It is a geologic control group because it's the outermost of the 4 Galilean moons. Callisto is not part of the orbital resonance and experiences very little tidal heating. Its dormant nature provides a perfect baseline to compare against the intense activity of its siblings. It shows us what a large icy moon looks like without the influence of tidal forces. 62. Hasn't changed much since its formation. Its ancient surface is a pristine record of the late heavy bombardment, a period early in the solar systems. History when asteroids and comets rained down on the planet. 63. It's composed of a roughly equal mix of rock and ice. Callisto is like a giant, dirty snowball. It's the least dense of the Galilean moons, and scientists believe it is not fully differentiated, meaning its rock and ice may not have fully separated into a distinct core and mantle. It might just be a jumbled mixture all the way through. 64. Yet, it might also have a subsurface ocean, despite its lack of tidal heating. Magnetic field data from the Galileo spacecraft hinted at the possibility of a liquid layer deep within Callisto. If it exists, it would have to be kept liquid by the slow decay of radioactive elements in its rocky interior, and perhaps insulated by the thick ice shell. 65. It features a massive impact basin called Valhalla. The most prominent feature on Callisto is Valhalla, a colossal impact structure. It has a bright central region about 600 kilometers across, surrounded by a series of concentric rings that stretch out for nearly 1,800 kilometers. It looks like a giant bullseye, a frozen ripple in the ice from a cataclysmic ancient impact. 66. Callisto is a potential future base for human exploration, because it is outside Jupiter's main radiation belts. Callisto is a much safer place for humans than the other Galilean moons. Its surface is rich in water ice, which could be used for drinking water, breathable air, and rocket fuel. It's being proposed as a potential forward base for a future human exploration of the Jovian system. Asterisk. 67. Jupiter currently has 95 confirmed moons, and this number is constantly growing as our telescopes become more powerful. Most of these are tiny, irregularly shaped rocks, just a few kilometers across. 68. Most of its moons are irregular. This means they have large, eccentric, and inclined orbits. Many of them also orbit in the opposite direction of Jupiter's rotation, a retrograde orbit. 69. These irregular moons are captured asteroids or comets. They didn't form with Jupiter. They were rogue objects that strayed too close to the giant planet and were snared by its immense gravity. They are now prisoners of Jupiter. 70. These moons are grouped into families. Astronomers have noticed that the irregular moons cluster into groups with similar orbits. The Calm and Ananke groups, for example, are retrograde, while the Himalaya group is prograde. It's believed that each family is the shattered remains of a single, larger body that was captured and then broken apart by a collision. 71. Comet. Shoemaker-Levy 9 showed us Jupiter's power in 1994. The world watched as a comet, previously captured and ripped into over 20 pieces by Jupiter's gravity, slammed into the planet one piece at a time. The impacts left massive, dark scars in Jupiter's clouds, some larger than Earth. It was a stunning, terrifying demonstration of Jupiter's gravitational might and its role as a cosmic vacuum cleaner. 72. Jupiter acts as the solar system's bodyguard. For a long time, the dominant theory was that Jupiter's gravity has protected Earth by absorbing or deflecting countless comets and asteroids that would have otherwise struck our planet. Without Jupiter, life on Earth might never have had a chance to flourish. 73. But it's also a cosmic sniper. More recent simulations have complicated this picture. While Jupiter does shield us from many long-period comets from the outer solar system, its gravity can also nudge asteroids from the asteroid belt into Earth-crossing orbits. So, it's both a bodyguard and a sniper, and the net effect on Earth's safety is still a topic of scientific debate. 74. Jupiter shepherds two giant swarms of asteroids. Jupiter shares its orbit with a group of asteroids called the Trojans. They don't orbit Jupiter, but are locked in a stable gravitational relationship with it and the Sun, congregating in two special spots called Lagrange points, one group leading 60 degrees ahead of Jupiter and one trailing 60 degrees behind 7.5. There are more Trojan asteroids than in the main asteroid belt. It's estimated that there are over 1 million Trojan asteroids larger than 1 kilometer. Combined, they may contain more material than the main asteroid belt between Mars and Jupiter 7.6. NASA's Lucy mission is exploring the Trojans. The Lucy mission is on a 12-year journey to visit multiple Trojan asteroids, a historic first. These asteroids are thought to be pristine relics from the formation of the solar system, fossils of planetary creation. And Lucy will give us our first up-close look at them. 7.7. The Grand Tack Hypothesis. One leading theory of solar system formation suggests that Jupiter didn't form where it is today. It may have migrated inwards, almost to where Mars is now, before tacking like a sailboat and migrating back outwards, pulled by the gravity of a newly forming Saturn. 78. This grand tack shaped the inner solar system. This migration would have been catastrophic. It would have scattered the material in the inner solar system, explaining the small size of Mars and the composition of the asteroid belt. It may have also delivered water-rich asteroids to the inner planets, including Earth, potentially providing the water for our oceans. Asterisk 7.9. Pioneer 10 was the first spacecraft to visit Jupiter. 1973, it was humanity's first crossing of the asteroid belt and gave us our first close-up images, confirming the severity of its radiation belts. 80. Pioneer 11 followed a year later, 1974. It took even more dramatic images, including the first pictures of Jupiter's polar regions. 81. The Voyager probes revolutionized our understanding. 1979, Voyager 1 and 2 were a quantum leap. They discovered Jupiter's faint rings, the volcanic activity on Io, and gave us the first hints of an ocean on Europa. Their grand tours of the outer planets remains one of humanity's greatest exploratory achievements. 82. The Galileo spacecraft was the first to orbit Jupiter. 1995 to 2003, despite a crippling antenna failure, Galileo was a triumph. It dropped a probe into Jupiter's atmosphere, which survived for 58 minutes, sending back data on pressure, temperature, and composition before being destroyed. The orbiter then spent 8 years studying the moons in unprecedented detail, gathering the key evidence for the subsurface oceans of Europa and Ganymede. 83. The Galileo probe was deliberately crashed into Jupiter at the end of its mission, to avoid any possibility of contaminating the potentially life-bearing moon Europa with earthly microbes. NASA sent the Galileo orbiter on a final, suicidal plunge into Jupiter's atmosphere in 2003.84. The Juno mission is giving us an unprecedented view. 2016 present Juno is our current eye on Jupiter. It's in a unique polar orbit, allowing it to study the poles and avoid the worst of the radiation. Its goal is to understand Jupiter's origin, structure, atmosphere, and magnetosphere.85. Juno is armored like a tank to survive the intense radiation. Juno's sensitive electronics are housed inside a 180 kilogram, 400-pound titanium vault, shielding them from the constant particle bombardment. 8.6. Juno proved Jupiter's stripes go deep. Data from Juno's gravity measurements showed that the zones and belts, the jet streams we see on the surface, are not superficial. They penetrate about 3,000 kilometers, 1,860 miles, into the planet's atmosphere. 87. The James Webb Space Telescope has captured stunning images. The JWST's infrared eyes have given us a new perspective on Jupiter, showing incredible detail in its auroras, hazes, and storm systems, revealing the complex interplay of its atmospheric layers. 88. Jupiter is named after the Roman king of the gods. This is fitting for the largest and most massive planet in our solar system. 89. Its moons are named after his lovers and attendants. In Roman mythology, Jupiter, or Zeus in Greek myth, had many lovers. Io, Europa, Ganymede, and Callisto are all figures from these myths. 90. Jupiter takes nearly 12 Earth years to orbit the Sun. One Jovian year is a long time. This means it spends about 1 Earth year in each of the 12 constellations of the zodiac. 91. You can see Jupiter with the naked eye. It is the fourth brightest object in the sky, after the Sun, the Moon, and Venus. On some nights, it can even outshine Venus. 92. Jupiter has a very faint axial tilt. Its axis is only tilted by 3 degrees compared to Earth's 23.5 degrees. This means Jupiter has no significant seasons. The weather you see is the weather you get all year round. 93. Jupiter is still shrinking. It radiates so much internal heat that it is actually shrinking by about 2 centimeters every year. 94. A great cold spot exists in its upper atmosphere. Similar in scale to the Great Red Spot, this vast vortex of cold gas was discovered in Jupiter's high-altitude thermosphere, linked to the powerful energy of its AURORAS. 95. Its magnetic field reverses polarity. Like Earth's, Jupiter's magnetic field is not static. Geologic records on Ganymede could theoretically show evidence of these flips over billions of years. 96. A day on Jupiter is different depending on where you are, because it's not a solid body. Jupiter rotates faster at its equator than at its poles. This is called differential rotation. System I, the equator, has a day of 9 hours 50 meters, while System II, higher latitudes, is 9 hours 55 meters. 97. It is the fastest spinning planet. This rapid spin is a leftover from the angular momentum of the gas and dust cloud that it originally formed from. 98. Jupiter's influence may have prevented a planet from forming. The asteroid belt is located in a region where a planet could have formed, but Jupiter's immense gravity constantly stirred up the planetesimals there, preventing them from ever coalescing into a single large body. 99. The study of Jupiter helps us understand exoplanets. Many of the first exoplanets discovered were hot Jupiters, gas giants orbiting extremely close to their stars. By studying our own Jupiter in detail, we build the models needed to understand these distant worlds we can never visit. 100. Jupiter is a reminder of possibility. This is perhaps the most profound fact of all. The Jupiter system is a testament to the sheer diversity of worlds the universe can create. It has a failed star, a volcanic hell, a giant's giant, an ancient relic, and most tantalizingly an ocean world that might harbor life. It is a solar system in miniature, showing us that the most incredible discoveries may not be light years away, but right here in our own cosmic backyard.